All right, today we're going to make our first two parts that use the circular pattern tool. The first of which is this part that we will call 5 holes that uses 5 holes along a circular pattern. The first thing we need to do, as always, is create our new component. And now we just need a metal disc to drill these holes into. So I'm going to start a new sketch, use our circle tool, and make a 4-inch diameter circle. I'll finish sketch, and I'll just press pull this guy, make him 1.5 inches thick. Now the next thing we need to do is we need to add points to mark off where we want our holes to go. So I'm going to create a sketch on top of this disc, and if I click the arrow next to create, I can go down and select point. This allows me to mark off locations. I'm going to put one straight up from my origin, and then I'm going to dimension that point 1.25 inches out. The circle, if you look here on the left, has a 2.5 inch diameter. Since we are measuring the radius from the middle, it will just be half that. Now, rather than draw all 5 points and try and line them up perfectly, we can use a new tool in the Create panel called Circular Pattern. With Circular Pattern, I can select the object I want to pattern. In this case, I'll click the point. You can see it says one selected. Now I'll click center point and click my origin, which will be the middle of that circle. And you can see it's created 3 of them by default. I could create 3, I could create 30. I could even go through and check and uncheck specific points to turn them on and off. In this case, I just want 5 points, and I'll click OK. Now I can finish sketch and come up here to use the hole tool. Now the hole tool is used whenever we want to make a hole designed for a screw to fit in. If you're just making a standard circular hole or rectangular hole, I recommend just starting a new sketch, drawing the shape, and press pull it through. But if you're making a hole specifically designed to fit a screw, then you're probably going to want to use the hole tool. So I'll click the hole tool. The first thing I need to do is select my point for my first hole. And now you can see I've got a whole bunch of options here. The options over here on the left should sync up relatively well here on the right, although they're a little bit rearranged. For instance, here it's referred to as termination. Over here we have extents, and that's how deep does this hole go. For our first hole, our termination is through all, so I'm going to change our extent to all. We've got a simple hole, which is that first symbol here. We have simple hole tap, which just means nice smooth sides, which is that symbol here. Drill point, we are going to want to change to flat. And then now down here, we have to add our hole diameter. For this hole, our diameter is 0.25 inches. And that's it. Time to make hole number 2. But before we can make hole number 2, we have to bring back those 5 dots. So in order to bring back those 5 dots, I'm going to come here to my browser, click the arrow next to component, and I can find my sketches down here. Fusion 360 operates on a one and done mentality. If you make a sketch and use the sketch, it automatically hides the sketch, figuring you're done with it. But we can go back and just click this little eye next to sketch 2, and that will bring back the sketch with those 5 points. I'll click hole and pick my second point. Now if we look at our second hole, that's a counter bore hole. Our termination is through all, so I'm going to change my extent to all. For hole type, I'm going to pick the second one, counter bore. A counter bore hole has a wider top to the hole. It's designed so that when you're screwing in a button head screw, a nut, a bolt, it can be recessed down into the part, giving you a nice smooth surface. Let's see, my counterbore width is 0.75, counterbore depth 0.25. So 0.75 and 0.25. And then my hole diameter, 0.375. Click OK. And you can see this counterbore hole gets wider at the top in order to accommodate a nut, a bolt, a screw head. For our third hole, we're going to do a countersink hole. A countersink hole is very similar to a counterbore hole, except instead of a rectangular top, it has an angled top designed to hold screw heads. Again, the objective behind it is so that the screws will go down into the part, leaving a nice smooth surface. We can see our termination is through all. Our hole type will be countersink. Simple hole tap, flat drill point. We can see up top our countersink diameter is 0.75 inches. Our countersink angle is 82 degrees, and our hole diameter is 0.375 inches. Our fourth hole is a tapped hole. A tapped hole is designed to have threads cut into it so that you can screw a bolt or a screw directly into the part. So I'm going to go to hole. Looks like my termination is through all again, and I'll pick my point. Hole type, I'm going to go back just to a simple hole, but now where it says hole tap type, I'm going to click the third one, tapped. Now I can come down here, and what we want to do is we want to match the screw settings. Fusion 360 has a content library with thousands of different types of nuts, bolts, and screws. All you have to do is pick the specific screw you want, and it'll automatically pull the measurements. So we've got ANSI unified screw threads. Our size is 0.25. Designation, 1/4 inch 20 UNC. Class 1B, and right-handed. Now, if I click OK, it will pull up that information, and you can see right now it just sort of draws a spiral on the inside so that we know that it's threaded. You also have the option of clicking modeled, and now instead of drawing that, it will actually carve the threads into the model. This would be useful if you're going to 3D print this part, in which case it would 3D print the threads as opposed to just showing the threads. Our final hole is a clearance hole. This is a larger hole designed to fit a screw head when two parts will be connected together, or you have to screw one part through another part. So I'm going to click hole, click my fifth point, termination through all, simple hole type, except now we want a clearance hole tap type. And again, all we have to do is pick what size screw or what size bolt we want it to be able to fit. In this case, we want ANSI unified screw threads. We want a hex head bolt. Our size is 1/2 inch, and our fit is normal. Click OK, and now we have our clearance hole. The final thing to do on this sketch, or this design, is now that we are done with our 5 points, I'm going to come to Sketch 2 in the browser and click the eyeball to turn that visibility on that sketch back off. And that is the 5 holes part. The next part we're going to make is a nice quick one, and that is this disc brake right here. It too uses circular pattern, but it also incorporates revolve. So I'm going to create my new component, create a sketch. Now the interesting thing with this sketch is we don't start at the origin. I'm going to draw my shape floating up into the air here. The reason for that is when we want a circle, we want a hole right in the middle. So this way, when we revolve the shape, it'll also leave that gap there for us. When we come to dimension, looking at that sketch, we can see that all of our heights are measured from the origin itself. So origin to this line is 1 inch, origin to the top, 2.5 inches. We've got a width of 1 inch, and then our upper width is 0.5 inches. Now you can see my part is still blue. That's because he can still slide back and forth because we didn't start at the origin. So what I'm going to do is I'm going to come up to my constraints and use a vertical constraint and say that, hey, this point and my origin have to line up straight up and down. Now I can finish, go to revolve, and I'm going to pick this axis. And you can see as I revolve it, it automatically revolves that hole in the middle as well. Now we need to add these circles here. It's kind of hard to see, but the distance from the center is 1.65 inches, and we're going to go with a 1/2 inch diameter for the hole. So I'm going to create a new sketch on top, and I'm just going to put a point that I'll dimension 1.65 inches out. Now we could finish sketch and use the hole tool, but since this hole is just a simple circle, I'm just going to sketch a circle right onto that point. 0.5 inch diameter circle. Finish, and I will press pull this guy through the bottom. Now, to create all 10 of these circles, just like with the points on the 5 holes project, I'm going to click create. I'm going to come down here to pattern, and I'm going to pick circular pattern. The object that I want to pattern is this hole. My axis, so the middle of the pattern, I'll just pick the middle of the circle right here. And our quantity is 10. We do that. We now have the holes for this disc brake. The final thing is there is a little groove cut to fit what is called key stock. That's actually what locks the disc brake and the axle together. So I'm going to create a final sketch on top here. Under my create rectangle, I'm going to go with a center rectangle. And right here, I'm just going to draw out a rectangle and make him 0.125 by 0.125 inches. Now I do want to get him lined up right above the middle, so I'm going to come back to my horizontal vertical constraint and make the middle of that rectangle straight up from my origin. Finish. Go to a nice isometric view. And now I can just press pull this guy through to make the cut for that key stock. We'll go ahead and save this part as disc brake.